In quadratics, there's something that's called the discriminant. The discriminant is part of the quadratic formula, and it's the part that's underneath the radical. So the value of the discriminant is b squared minus 4ac. When evaluating this value, the biggest thing that students mess up with is including the square root. The square root is not included in the discriminant. So don't take the square root when we find the discriminant. I just want to know what's under the square root. So the discriminant tells us two things. It tells us first how many solutions there are, and then it also tells us what kind of solution there are. So if the value of the discriminant, so b squared minus 4ac, is greater than 0, there's going to be two real solutions. If the value of the discriminant is equal to 0, then there's going to be one real solution. And then this last part, if the discriminant is less than 0, meaning it's negative, then this means we're going to have two complex solutions. And complex solutions are new for us. They're going to involve imaginary numbers, which we will talk about very shortly. But first, with the discriminant, let's see what these look like. So, if there are two real solutions, then that means when I graph my quadratic, it's going to cut through twice. Right here and right here. Two real solutions. I can see them. You could also have it opening down, but still cutting through the x-axis 2 times. If our discriminant equals 0, that's where we have one real solution. Meaning, we're still going to see it, it's real, but it hits only once. So it hits the x-axis right there, and then it bounces up. And again, it could also be opening down, hitting the x-axis just once, right here, and then going back down. So if we were to graph a function or a quadratic that had two complex solutions, then it wouldn't hit the x-axis at all. So it can open up or open down without touching the x-axis. So this means that we can't see real solutions, so therefore there are two complex, two imaginary solutions. And these solutions to these quadratics, as a reminder, are the x-intercepts, the zeros. So let's do some practice problems. If I gave you the quadratic function x squared minus 8x plus 7, and I said find the discriminant and determine how many and what kind of solutions there are, your first step would to just do b squared minus 4ac and then evaluate this value. So b is negative 8, so negative 8 squared minus 4 times 1 for A times 7 for C. And when I evaluate this number, I get 36. Well, 36 is greater than 0, so this means that we have two real solutions. The next example, 2x squared minus 2x plus 1. I'm going to set them equal to 0 because we're solving. If you find the discriminant, this is going to be negative 2 squared minus 4 times 2 times 1. And when you do this, you're going to get negative 4. Well, that's less than 0, so this means that we're going to have two complex solutions when we solve. And our final example, x squared plus 2x plus 1 equal to 0. This would be 2 squared minus 4 times 1, which equals 0. So if our discriminant equals 0, this means we have one real solution. And again, if we were to graph these, this first one would cut through twice. This second one wouldn't cut through at all. It would look like this, the x-axis I mean. And this third one would touch it, but then go straight back up. So right now we're just determining how many and what kind. Eventually we're going to solve. You already know how to solve if you had two real or one real solutions, but we're going to get into solving when we have complex solutions.